Recording in progress.
Okay, Andy. Good morning, everyone. Online students, can you hear my voice? Say yes or no to me once. Here. Yesterday, I took one concept known as polymorphism. I taken. So let me conclude that once. Right. Somebody said I loaded wrongly, they said, yes, sir. Here. This is demo exception 5 or 4. This one I loaded wrongly. This one only. Just 5, I think. Instead of demo exception 4, I copied demo exception 5. That only no problem. Right. This is demo exception 4. I'm copying here. In yesterday's notes, I'll copy there. Demo exception 4 and 5 will be there. One minute, I'll copy it and we'll start. This is 7. Right. Now the notes is so don't be confused again. The notes I updated like this. Here, demo exception 4 I kept. What I loaded wrongly. Down I kept your yesterday's notes. Like this. Okay. So that I can be in a separate unit polymorphism if I update. Okay, right. The notes is updated correctly. Check it out. Now, today's class is polymorphism. Poly means many, morphism means forms. The process in which programming components having more than one form is known as polymorphism. Like this. Suppose I am taking one interface like this. I comparable one interface. Some int is the return type. Here some compare to of int x comma int y. This is one abstract method. This is one abstract method. Now here, two implementation classes. Always I'll take greater and smaller. I'll take greater class and I'll take one smaller class. I will take it. Smaller class. I will take it. Here to here we had implements. Implements is there and here implements is there. So what is the rule here now? Sir, take this compare to method. Take this compare to method and write the body. Take this compare to method and write the body. Int compare to of int x comma int y. Here we had greater logic. Int compare to of int x comma int y. Here you can have smaller logic, greater logic and smaller logic. Now if you observe carefully here, sir, this compare to method, same method, name same only, no? Right. This compare to method is having two forms. This is one form and this is one form. Two forms are there. Two different forms. This is one form one. Means polymorphism means different forms, no? Right. Same method having two forms. It can do greater logic, it can do smaller logic, but you are calling same method only. The method is having two forms through overriding. Through overriding, the method is having two forms. And moreover, through overriding, you can show that forms to user. Means when the execution started, you will say choice. You want greater, you want smaller. But in the background, you are calling the same method only because same method has two bodies. The statement through method overriding process. Through method overriding process, we can have more than one form for the same method signature at runtime. Make a statement. Note. Note. Through method overriding process. Through method overriding process, we can have more than one form to the same method signature. Same method signature. Through method overriding process, we can have more than one form. More than one form to the same method signature. Same method signature. More than one form to the same method signature at execution time. At execution time. Through method overriding process, we can have more than one form to the same method signature at execution time. Because of this reason, method overriding process comes under dynamic polymorphism, or you can say runtime polymorphism. You can say dynamic polymorphism, or you can say runtime polymorphism. You can say through method overriding process, we can have more than one form to the same method signature at execution stage, at execution time. Because of this reason, method overriding process comes under dynamic polymorphism or runtime polymorphism. So example of dynamic polymorphism is method overriding. How? If anybody asked, this paragraph you have to say. If we cannot understand this paragraph, draw like this one diagram and say that same method has two different forms. It can do logic, greater logic. It can do smaller logic. Two forms are available to user at execution stage. That's called runtime, many forms. So concept. Now quite opposite to it, method overloading. Method overloading. See there. In method overloading, what happened is, I am taking application related to polymorphism concept. I'll take P1 and P2. P1 and I'll take P2. Suppose under P1, I'm taking one class as addition. I will take roughly for demo purpose. I'll take addition. I want write overloaded methods. I want write overload. Overload means what now? Sir, more than one method with the same method name, but difference in their parameter list or parameter type. So I am taking one method, public void add of int x comma int y. This is one method. I'll take one more method. Public void add of int x comma float y. So error will not come because this is separate method. This is separate method. Method name same only. But there is a difference in the parameter list or not now. Here parameter list is 2. Difference in the parameter type, not list. Parameter list is same, no? 2 and 2. But here int and int. Here int and float. Now, so public void add of int x comma int y comma int z. Now, same method having 3 different forms. One with 2 parameter, one with 2 parameter, one with 3 parameter. But here, one integer, one float. So finally, sir, add method is having int comma int, one form. Add method is having int comma float, one form. Add method is having int comma int means same method having 3 forms. Now these 3 forms are detected by whom? These 3 forms are here, the 2 forms are detected by the user. First case, the 2 forms are detected by the user at execution. Here 3 forms are detected by whom? See, who detects means if I write int y here, error will come. So who is giving error now? Compiler is giving error. Compiler says that there is a duplicate method is saying. Means what? Compiler is identifying that method form. So compiler at compilation stage identifies there are 3 forms available. Previously, I took float and float or not now? Float and float. Then error not there here. Whenever you take a float here, error not there. I asked compiler, why error not there? Compiler says that at compilation stage, I am seeing add method having 3 forms. The 3 forms are at compilation stage. Because of this reason, overloading comes under static polymorphism, or you can say compile time polymorphism. It's a theory. Make a statement. Through THROUGH, through method overloading process, through method overloading process, we can have different forms for the same method. Different forms for the same method by differentiating parameter list or parameter type. Through method overloading process, we can have different forms for the same method by differentiating parameter list or parameter type at compilation stage. At compilation stage. Because of this reason, method overloading process comes under static polymorphism, or you can say compile time polymorphism. You can say static polymorphism, or you can say compile time polymorphism. You can say through method overloading process, we can have different forms for the same method by differentiating parameter list or parameter type at compilation stage. Because of this reason, method overloading process comes under static. Static means unchangeable here. Static polymorphism or compile time polymorphism. You take like this example, add is having three forms like this. Down, I'll copy this. The small program, I'll copy there. Like a class, I'll copy. Demo purpose, no. Like a class, I'll copy. You copy like a class. Empty bodies I kept for demo purpose. Already you know overloading, overriding already through inheritance chapter. Right. So these statements are nothing but how overload comes under static, how override comes under dynamic. These paragraphs you have to speak. Now, when the compilation process is going on, compiler will understand the behavior of few keywords like static, private, and final. They will understand. Means compiler clearly understands the behavior of static components, private components, and final components. Make it. The compiler at compilation stage will understands the behavior of the following keywords. The compiler at compilation stage will understand the behavior of the following keywords. 1. Static. 2. Private. 3. Final. Static, private, and final. The following are the static programming components. The following are the static programming components. Static variables, static methods, static blocks, static classes, static interfaces, static abstract classes. static variables, static methods, static blocks, static classes, static interfaces, static abstract classes. Static variables, static methods, static blocks, static classes, static interfaces, static abstract classes, static constructors not available. So what is missing here means static constructor. There is no concept of static constructors in Java. There is no concept of static constructors in Java. There is no concept of static constructors in Java. Right. All the components yes or no, na? Static variable. The variables which are declared with a static keyword outside the methods are known as static variables or class variables. These variables will get the memory within the class while class loading and can be accessed with the class name. This is a theory. Static methods. The methods which are declared with a static keyword, we call it as static method or class method. The static methods will get the memory within the class while class loading and can be accessed with the class name. Coding rule. Static methods can access static variable directly but cannot access instance variable. Friends, you cannot declare it as a static. If you don't follow this rule, compiler will give the error. Means compiler will understand. That's the meaning. So static components done. What are not done now? Private not done. Make a heading. Private. The following are the private programming components. The following are the private programming components. Private variables, private methods, private constructors, private classes. Private blocks will not be there. Private interfaces will not be there. Private abstract classes not there. There is no concept of private blocks, private interfaces, and private abstract classes. This concept not available. Private blocks not there. Private interfaces not there. Private abstract classes also not there. The variables which are declared with the variables which are declared with private keyword are known as private variables. Private variables. Right. Look here. I'll take one program here to declare some private variables. I'm taking one class P display. I'm taking one class as P display. In this class now, I'm taking one private variable. I'm taking int a is equal to 10. Private static int b is equal to 20. The meaning of that declaration is static variables can be private. Instance variables can be private. It's a meaning. This private concept is nothing but whenever you declare some variables as private, the variables will not come outside the class. They are not visible outside the class. If you want to print them, you have to take one method inside. Suppose I am using one method known as access. I am using one method. Now, system.out.println. I am trying to print private variables. Private variables I am trying. I am trying to print private variables. Now, system.out.println. So, the value a is equal to plus a. System.out.println. The value b is equal to plus b. So coding rule is private variables are accessed only by the methods declared in the same class. That's the rule. If any method available in the same class, they can access this private variable. Unless private variables will not come outside the class. Make it coding rule. Private variables are accessed by the methods which are declared within the same class. Private variables are accessed by the methods which are declared within the same class. Wherever the variables are there only if methods are there, the methods can access. Private variables are accessed by the methods which are declared within the same class. Within the same class. Private variables are accessed by the methods available in the same class. That's the meaning actually. Sir, where I can use private variables in your advanced Java? Bean classes, bean objects will come. In that bean class, bean object, it's a mandatory rule. You have to declare variables as private. Make it. Note. In real time, The private variables are declared in bean classes. Declared in bean classes. In real time, the private variables are declared in bean classes. Bean classes means server programming. You can see that bean class. Right. Now see. All of you understood this statement? Let's underline the bean class and keep it because the term used by your advanced Java trainer, chapter number 2, servlet. So there he is going to use a term known as bean class. The bean class rules will be there. The first rule is nothing but variables are private. Whenever variables are private, you must remember my rule, core Java. The variables are accessed by the methods which are declared in the same class. That rule you have to remember it. Now, here I declared one non-private method and variable. To run this method, I must create object for it. So I am creating object. Under P2, I am taking one class as demo poly1. Demo poly1. Polymorphism 1. I am importing import p1.pDisplay. I am creating object. So pDisplay OB is equal to new pDisplay. Now this is constructor call, no? Yes or no? Na? So whenever we call a constructor without parameter, here constructor available or not available? Here constructor available or not available? You must say not available. If it is not available, how it runs? If anybody asked, then you must say in the compilation stage, compiler will add one constructor. What is the name of that constructor? Default constructor. The constructor is public constructor only. It will add public constructor only. It will add. So this is the constructor. Of course, compiler added, but I am showing manually to you, right? Constructor added. So this is constructor call. Using this, I can call ob.access. I can call the method. Automatically, private variables are displayed. All of it clear? Right. Now comes private methods. Private methods. The methods which are declared with private keyword. The methods which are declared with private keyword are known as private methods. The methods which are declared with private keyword are known as private methods. Are known as private methods, you can say. Private methods, you can say. Right. Now see, I am writing private methods here. Inside this pDisplay, I am writing private void display 1. I am taking. I'll take one more private static void display 2. I am writing. So it can be static method and non-static method. Int x and int y. So here system.out.println. So it is private method. The answer is coming from private method. I can say display 1 of X, I can say. The value X is equal to plus X. Display 2 of Y. Now, private methods also will not come. They will not come outside the class. So any other non-private method must access. So through this method, you have to access. Here. So, private methods. I am running private methods. Whenever I want to call these private methods here, so this dot display some value. Whenever I want to call the static method, I must call with class name no p display dot dis some 20. So non-private method calling private methods. If you run it, answer will come. Private methods answer is coming or not now? Private variables, private methods. So coding rule here. Coding rule. Private methods are accessed by the non-private methods of same class. If any non-private method is there, they can access private methods. Unless private method will not come. Private methods are accessed by the non-private methods of same class. Access is a public method. It is not private method. So you can say non-private method. Now, sir, where we can use private methods? Private methods are less used. Almost we never use. So for security reasons only we use private method. So private methods are less used when compared to other methods. I am not recording the statement. The statement you should remember it. So private methods are accessed by the non-private methods of same class. Right. Now go for third one. Private constructor. The constructors which are declared with private keyword are known as private constructors. The constructors which are declared with private keyword are known as private constructors. The constructors which are declared with private keyword are known as private constructors. Look here. What is the coding rule here? Private means inside the class, no? These private constructors are executed. These private constructors are executed when the objects are created inside the same class. When the object is created inside, the constructor will run. These private constructors are executed when the objects are created inside the same class. When the objects are created inside the same class. Right, look here. Then how, sir? This object, see there, this constructor I am declaring with private. Whenever I write private constructor, here error will come. The constructor P display is not visible. The constructor will not come. Constructor is a private, no, inside. So you must create the object inside only. Okay. Inside this access method, inside that access method, I'll create object P display. P display OB is equal to new P display. I created object inside or not now? Sir, this is constructor call. When the object is inside the same class, the constructor will run. Now, whatever the object created here, whatever the object created here, now this access method will return that object void. Return type is what now? P display. I'll make this method as static. I'll make this method as what now? Static method, I'll make it. All of you observe this fine now, right? Okay. Whenever I use a static keyword here, this is static. Static method cannot access instance variable, no? Yes or no, na? And this keyword you cannot declare inside the static method, no? Right. Sir, why you use a static keyword here? The reason, I can access this method by using class name, no? Because object not there. Because here error coming, no? Object not allowed here. This is error. Sir, here error is there for us. But object should come out. How it will come now? P display OB is equal to P display dot access. The method will come out or not now here? So here, no need to run. You can call with class name no, directly. P dot display, we are calling the method or not? No, directly without object. So access method. But here, this keyword not there. So better you create object here. Access this A with OB. You can access. Display your access with what now? OB. You can access. RETURN. Return OB. The answer is coming or not? It has to return the value or not? No, OB. It has to return. There. If not, sir, no need to return, sir. Take it as a void. Remove this return. This also correct only. Because in this method, I am creating object to call the constructor. Constructor call is inside. Variable calls are inside. Method calls are inside. Means all private members are available inside the class only. Now the answer will come. See there. Let observe it. Private variables used by the methods of same class. Private methods used by the methods of same class. Private constructor executed when the object is created inside. Means privates are inside the class only, they are not coming out. But whenever I want to access this access method, I made it as a static. For static object not needed, no, you can call it. Directly you can call pdisplay.access. You can call. Directly the method is coming and answer is coming. So finally, private constructors available or not? Yes. They'll ask a question. Can you declare a constructor with a private keyword? Yes. The constructors which are declared with a private keyword, you can call it as private constructors. These private constructors are executed when objects are created inside the same class. It's a theory. Right. All of understood this code? Says or no to me? All are inside only. So private variables, private methods, private constructor. Last one is there. Private class. The classes which are declared with private keyword are known as private classes. The classes which are declared with private keyword are known as private classes. The classes which are declared with private keyword are known as private classes. Right. Coding rule, same. These private classes are declared only as inner classes. These private classes are declared only as inner classes, which means outer classes cannot be private. Outer classes cannot be private. These private classes are declared only as inner classes, which means outer classes cannot be private. Outer classes cannot be private. So I'm taking private inner classes now. I'm taking private inner classes. I'm taking. Now see the program. Inside this class now, I'm taking private class subclass 1. I'm taking private inner class public void sum m1 of int y. If not p, you take it. M1 of p. Now system.out.println the value p is equal to plus p. I am taking one static again. Private static class subclass 2. This also private inner class only. Private inner class. M2 PQ. Like this. Finally, you can declare private classes as inner classes. For them also, I'm creating object in the access method only. I'm creating. See there. Subclass what? OB1 is equal to new subclass 1. That is inner class, no? Right. Spelling. Ah, static cannot access instance, no? Yes or no, na? Static cannot access instant. This is static, no? Right. Right. For this class, I'll keep variables outside. Subclass 1, OB1 is equal to new subclass 1. Subclass 2, OB2 equal to new subclass 2. I'll take these variables as static, as a static. Subclass 1, right. This I took because object is inside, no problem. Like this. OB object is there, no? Right. OB dot OB1 dot M1. OB dot OB2 dot M2. I'll explain it. The answer should come first. Here, system dot out dot println. Here, private inner classes. Private inner classes. These are private variables, private methods, private inner classes. Now look here. Here object must be created anyway. I want to bring the objects inside. I brought successfully inside. So all are inside. My intention is that. Right. I'll explain it once. So answer is coming now. Now see there. All of you remember inner classes? Right. Okay. Now see. You will understand. Nothing is there. Sir, for this, we are creating one object. For this, we are creating one object. So that is outer class object. This is outer class object according to inner classes. For these inner classes, who is outer class now? This is outer class. This is outer class. For this outer class, we had an object here, OB. Whenever we want to create object for instance member inner classes, what is the rule now? Outer class name dot inner class OB equal to outer class object name dot new inner class. That only. Outer class name dot inner class OB1 is equal to outer class object dot new inner class. All have understood the statement now. So you are creating object for instance member inner class. Means this is private instance member inner class object. This is static, no? Outer class name dot inner class OB is equal to new. I must write here actually, but directly object is created. But I must write what now? Outer class name I must write. P display dot subclass I must write. Have you understood this? Right. So this is private static member inner class. So this is private static member inner class. Finally, you can declare private variables, private constructor, private methods, private inner classes you can declare. So these private inner classes only possible, outer classes cannot be private. To access that private components, I am using a single method access. I am creating object for P display to call the constructor because constructor is executed when the object is created inside. I am accessing the private variable. I am accessing the private method. If it is an instance method, I am accessing with object name. If it is a static method, I am accessing with a class name. Private inner class objects. I declared one instance member inner class. I declared one static member inner class. I am creating objects inside the same method and calling. So if I run it, I'll get the answer. So all are private. Among this, which one important means private variable, bean classes, private constructor for singleton class design pattern. Tomorrow it will come question. Okay, right. The third one is private inner classes for security. They brought private inner classes for security. They brought it. You can write private inner classes for security layers. You can write. So make that statement here. Note. In real time, private inner classes are used in protection and security layer of applications. Whenever you want to write any protection logics, security logics, they'll take the support of private inner classes. They will take it. So example program P1 P display dot Java. I used all components inside and demo polymorphism 1 dot Java, the main class. Here the output. So private variables are there, private methods are there, private constructor is there, private inner classes are there. Private classes means only inner classes. You cannot declare outer class as private. Error will come. So this program is demonstrating the components. But where we use private generally means we use private for singleton class design pattern. The design pattern I'll write tomorrow separately. Today program only for components. Just declaring the components. Okay, right. And the last one is final. The last keyword is what now? Final. Compiler will control final also. The following are the final programming components. The following are the final programming components. Final variables are there. Final methods are there. And final classes are there. Final variables are there. Final methods are there. Final classes are there. Final classes are there. The variables which are declared with final keyword in classes are known as final variables. The variables which are declared with final keyword in classes are known as final variables. What is the coding rule now? Final variables must be initialized with values, and once initialized cannot be modified. Final variables must be initialized with values, and once initialized cannot be modified. Cannot be modified. In bracket. These final variables are also known as constant variables. These final variables are also known as constant variables, or you can say secured variables. You can say secured variables, you can say. Explanation tomorrow for this. That private also conclusion tomorrow only. Today only components. Conclusion tomorrow. Tomorrow you will understand where you will use private. So today only components. How to declare that components. Here notes for final. The methods which are declared with final keyword are known as final methods. The methods which are declared with final keyword are known as final methods. Coding rule, these final methods cannot be overridden. These final methods cannot be overridden, which means cannot be replaced. Cannot be replaced. These final methods cannot be overridden, which means cannot be replaced. Replacement not available for final methods. So final classes. The classes which are declared with final keyword are known as final classes. The classes which are declared with final keyword are known as final classes. Are known as final classes. General meaning. What is the meaning of final class? If I say today is the final class, what is the meaning? Sir, tomorrow no extensions are over. Final class in the project means last. So extension not available. Final class means no extension, no inheritance. Inheritance is not allowed. That's called final. So coding. Coding rule. Final classes cannot be extended or cannot be inherited. Cannot be inherited, which means no inheritance. No inheritance for final classes. No inheritance for final classes. No inheritance for final classes. There is no inheritance for final class. Right. Here, I forgot to make one statement. After this one line if possible. There is no concept of final blocks, final constructors, final interfaces, and final abstract classes. This concept not available. Final constructors not there, final blocks not there, final interfaces not there, final abstract classes not there. Only three components available: final variables, final methods, final classes. In inheritance chapter, finally block, not final block. Don't be confused. Final block not there. Finally block is there. In interview, they'll confuse you. They'll ask, what is the difference between final block and finally block? They'll ask. Then Venkatesh sir, skip to final block, you will think it. But final block not there. Answer, finally block is part of exception handling process. There is no final block. That is the answer. You cannot declare one block with final keyword. The meaning. Very important question. That is final blocks not available. So tomorrow conclusion. Today only notes came. Right? Only components notes came. Tomorrow based on this final, one program will come, one rule will come. Then where we are going to use private, tomorrow conclusion will come. So tomorrow the chapter ends. This only chapter. Why we came to polymorphism, tomorrow you'll get a clarity. Tomorrow conclusion. Okay, right. And immediately we are going for introduction to strings. Today I started late. I went home and came, started late. Tomorrow in time I'll start it. Tomorrow I'll complete first half an hour, I'll complete your polymorphism. Next 30 or 40 minutes, I'll be into string chapter. When the string chapter started only, you can prepare questions for examination. String and arrays. These two chapters will come back to back. Right. Take a break. Yesterday's notes I updated today. The reason, yesterday somebody asked me, sir, you updated wrongly, they said. Wrongly means I must, I will not check again. I will check in today only, I must check it. So I not loaded. Now I'll load the notes. Do it and come. Take a break. Thank you very much for today.
పర్నేమ్ మెథడ్ లేకుండా పర్నేమ్ మెథడ్ యూజ్ చేయకుండా ఇంపోర్ట్ చేయకుండా నేను పర్నేమ్ మెథడ్
ప్యాకేజ్ ఎంత కాదు
అవును సార్ ప్యాకేజ్ ఇంపార్ట్ చేస్తాను
ఫుల్లీ క్వాలిఫైడ్ నేమ్ ఉంది అందరూ వచ్చారు అది ప్రాసెస్ కాదు
అలా చేయలేదు
ఇక్కడ వస్తుంది మార్క్స్ పర్మనెంట్ అడ్వాన్స్ ఎవరు